Okay, we're going to start on this accurate model 153, I believe it is, accurate signal generator and tracer. We have not finished the radio yet at the time I'm making this, because we have not got the output transformer mount in yet, but we're starting this. So what we're going to do now is we're going to take out the screws, and I believe there's 4 screws for the speaker. We shouldn't have to take that out, but I think these 2 here may have to come out, and there's a couple on the bottom that I think has to come out. Not sure about these screws right here, so we'll do all that off camera and get this out. I got the schematic printed out, and not sure if I have the electrolytics in stock. I think I do. So we're just starting this video now. So let me get this out of the case and we'll be right back. Well, it's got 2 electrolytics in here, multi-section. So I only spent a little bit of time on the schematic here. You see the rectifier right here. Well, anyways, we got to spend some time checking this out. It looks all original to me. Okay, I unplugged the speaker connections here. The hole in the back of the cabinet for the cord is just barely enough. It's big enough just to get the cord through, so I can't pull the plug through. So we'll just simply leave the cord here and leave the cabinet on the bench like that, because it's just as easy to work on it. The cord's got plenty of length to it, so it's not going to be in my way. So let's see what we've got here. 80, 80, and 40. And 10 and 20. Wow, that's going to take a bunch of electrolytics, but let me just see something here. Let me get the flashlight and check and see if there's any discharge out of the electrolytic. Sometimes you can tell in the base here if there's any discharge. We're going to bring this up on a Variac and check, see how much current it's drawing before we do anything on it. We'll be very careful with that. Hey, look, I looked at them very close with a magnifier. I don't see any discharge. That don't mean they're good. So, yeah, we got a bumblebee right here. That would have to be changed. There's one thing very puzzling, and I checked the schematic very, very carefully here on the input. And I'll show you that on the schematic. First of all, here's the diagram for the audio probe. Okay. You can see to the right is your RCA type of plug, which is this unit uses. On the left-hand side is the probe pin. Then it's got a coax, but no capacitor, no coupling capacitor. Okay? That's the audio probe that goes directly into your input, which is right here. AF input, audio frequency input. There's your grounded shield, there's your coax. Follow the coax up. Follow it right up. And it goes to the grid. Absolutely no coupling capacitor whatsoever. That is a big mistake. That is a big mistake. You need a coupling capacitor. Okay, you got a resistor off the grid. You've got a capacitor down here, which goes to that grid. That's fine. But the input grid does not have a capacitor on it. So I'm going to add one. Here's the back of the input jack. I'd like to put BNCs on here, but I'd have to drill out those rivets and it wouldn't look too good. And there's your coax going, and it goes directly to the grid of the tube without any coupling capacitor. That's wrong. That's wrong. I don't care what anybody says. I don't care if it's designed that way. You're going to throw the bias off on the tube. So, here's what you can do. You can either add a coupling capacitor here, or you add it in the probe. Since I don't have the probe, I would have to make one, or maybe use the one from the ICO 147A, but that has a coupling capacitor in it. So that's what I have to do. That's one of the things that will be done in the future. Here's your AF attenuator. Of course, it's got the bumblebee, which will be changed. There isn't a lot of caps in here. That's these down here, which will have to be changed. Not sure what that is. Not sure. It looks like a domino cap. You got a bugger way in the corner there. It's going to be very hard to get at. This is more of a look over today on this video. Just to see what we've got, and we're going to fire it up. Fire it up! Fire it up! Oh, we're gonna fire it up here on the Variac. Make sure this is down. That's on. Variac is down to 0. And we're going to keep a very careful eye on the digital amp meter and the analog amp meter. If there's any high increase in current, we will keep an eye on that. Before we start that, we're going to put the voltmeter on the electrolytics. And apparently, both electrolytics are connected, the negatives are connected directly to the chassis. So we're going to get our voltmeter out, and we're going to clip the ground to the chassis, and we'll check each one of these sections and see what the voltage is, if we have any. We have not tested the tubes. I understand there's computer type tubes in here. I don't know if my B&K 606 would test them. That is the newest tester I have. So, we'll see. We'll be back. Don't go away. Oh, it's 36 volts. We'll turn it on. Now, we're not putting any, we only got 36 volts, so I don't expect anything on the meter. Yeah. We had 26 volts and the clip fell off. We're not drawing any current. 46 volts. $46 volts going in, 48 volts coming out. Nothing there. Nothing there. See what this one is. 48 volts. 49 volts. Okay. Still not drawing any current, so let's go to 60. Go to 70 volts. $73 volts coming out. 72 volts coming out. 76 volts coming out. 100 milliamperes being drawn. No noticeable current draw on the analog meter, which will respond a lot quicker if there is a short. We could use the dim bulb too on this, but we'll figure we'll bring it up really slow. Let's go to 81 volts. We're still drawing 100 mils. Let's get my ugly head over here, and I hit the zoom button by mistake, and I was wondering why I couldn't get the meters in focus here. Okay. All right, let's see what we got here. Nothing on that one. No voltage on that one. I don't know why. $94 volts on this one. 83 volts on this one. 92. 91. 92. Alright. Alright, now let me put some leads on it, on the speaker clips here. Let me bring my 3.5, I believe. All right, let's go to let's go to 110 volts. Motorboating. Probably a bad capacitor. I don't feel any hum vibrations. I don't think the electrolytics are bad. Let me 122 volts. 115. 114. 2.15. Now, she's running, she's still drawing at 100 mils. Got it up to 117 volts. It's still drawing 100 mils. And 128, 121, 120. All right, so about 128 volts at the highest. Okay. We're getting negative 0.163 volts. Negative bias on the audio input circuit on the grid of the tube. Okay, turn the volume all the way up. It shouldn't make any difference. No. So we are getting a negative bias. Not much, but we are getting it. Which means you got a negative, you're going to upset the bias going into this tube. So why there isn't a coupling capacitor? They must have omitted it somehow, whatever reasons, I don't know. But as I said, according to this here, and of course this could be wrong, maybe the coupling capacitor is in the probe, which I do not have with this. So I think the safest thing to do is to put a coupling capacitor in, but that's later. These caps are running cool. It's just getting a little warmth from the tube below it because it's on an angle. We're drawing about 100 mils at 117 volts, and we'll put it up to, we never get 122 here. The most we ever get is 120. That's what we're getting in the shop right here, and that's very good for us. Okay, so let's just see what we are on it now. Not much difference. Now, it may be insignificant, may not mean anything, but before we close out this part, I may throw this up there because I still, as I said, I got to work on this radio, but I can't do anything right at this time. So, this is the show and tell on this. I don't want to have too many things apart at the bench at one time. I like to get one thing done and get it out of the way. But as you can see, that's the output. There's the input. That's where you put your audio probe in, if you're using an audio probe. You see no coupling capacitor there. You got your shielded cable going right up and going directly into the grid of, I can't read that, it's smeared, but it's a computer tube. It's going into the grid of the twin triode, which is what that is, similar to probably a 12AX7 or an AU7 type of tube. So what I want to do is to run some ESR readings. I've got the blue ESR meter, but that'll be done either off camera or it'll be done on a video. This is not part one. This is a show and tell of the accurate model 153 signal generator / tracer. So you got to have a coupling capacitor on the slider of the audio level input, but this goes directly to the grid. With no capacitor. So that's one of the things that I noticed right off the bat when I looked at the schematic. Alright, so that's it. That's the end of the show and tell of the accurate 153, and I will be making a part 1 when I get done with the Zenith radio. Thanks for watching. By the way, this was made in 1962.